Hello everyone, I am Rachana. Now I am going to design and analyze the 23-story building. Here the question is given. Since the lateral loads are different, we have different stories. First story 1 to 8, and for different stories we have different live loads. First story 1 to 8 live load is 5 kN per meter square. First story 9 to 14 is 4.5 kN per meter square. First story 15 to 19 live load is 4 kN per meter square, and the beams and columns of different dimensions are given. Slab thickness is 150 mm and outer cladding load is given as 0.2 kN per meter. Wind loads are considered and the parameters are located in Bangalore. Now open the ETAP software, go to the file and go to the new model. First we have to set the initial settings, then we will define the material properties. Units in meters, section database is Indian, and the design codes of steel and concrete are these. Then click on OK. Then uniform grid spacing, the number of grid lines in x and y directions are 4 meters as per in the question, and spacing of grids in x and y directions are 6 meters and 6 meters. Then number of stories are, here we are going to design the stories of 23, and typical and bottom story heights are 3 meters. Then go to custom story data, then edit story data. Since all the stories are not similar, so we will edit the different stories. Edit story data, then go to the story 1 to 8 are different stories. Then in the story 8 set the master story, and similarly set similar to the stories of story 8. Next, story 9 to 14. Story 9 to 14. Then story 15 to 19, set 19 story as master story, then similar to the stories 19. Then 20 to 23 are similar to 23. Then click on OK. Then read only, click on OK. Then go to define, we will define the material properties. Go to define material properties, add new material, select the region as India, select the material type as concrete Indian and the grade is M40. Then click on OK, then click on OK again, add new material, then material type, now set material type as rebar, the grade is HYSD 500. Then click on OK, OK again, add new material here, in rebar mild 250 grade, then click on OK, OK again, click on OK, materials are defined, then go to define and section properties, then frame sections, then add new property, add concrete rectangular, give the property name, column of size 500 by 500 and material type as M40. Change the dimensions of depth and width 500 and 500 and 500. Then in reinforcement modify or show rebar, design type is column, then click on column, longitudinal bars of HYSD 500 bar and confinement bars of mild to 50 grade, do not change any value, then click on OK, then click on OK. Here since the properties are same, we have for different column we have to change the only column size, then go to add copy of property, change the property name of column of different size 550 by 550, then change the dimensions of depth and width 550 and 550, then click on OK. As the properties are same, then add copy of property, change the column of different size as given in the question, change the dimensions here of depth 600 and width 600, then click on OK, then go to add new property, select in special auto select list, change the property as column auto select, select the design type as concrete, select the design type as concrete. Here the 3 different columns have been added, then click on add, then click on OK. Next a new property concrete. Now we will define for beam for different sections 500 by 300, change the material M40, depth, change the dimensions of depth and width 500 by 300, then go to reinforcement details, design type is beam, longitudinal bars of HYSD 500, confinement bars of mild to 50 grade, top and bottom bars are 25 mm and 25 mm, then click on OK, then click on OK again, go to add copy of the property, do not change the properties as given, change the property name of different size 550 by 350, change the dimensions of depth and width 550 and 350, then click on OK, then click on add a copy of property, beam of different size 600 by 400, change the dimensions 400 600 by 400, then click on OK, then go to add new property, auto select list, give the name as beam auto select, change the design type as concrete, the given 3 beams are displayed here. Select the 3 beams, then click on add, then click on OK. Click on OK again. The beam and column properties have been successfully added. Then go to define, go to section properties, then slab sections, add new property, slab 150, give the name as like this, and the slab material is M40. Change here the thickness of slab is 150 mm as given in the question. Then click on OK. Click on OK again. Since slab, beam and column properties have been successfully added, then go change the stories here by clicking up arrow and down arrow. Since we will go to plan and we will go to the story 1, then apply, then OK. Now draw the given properties, column, beam and slab for the different stories. Select draw menu and select draw beam column. Select the quick draw columns. Select the property here, column auto select, then select all the region. Here select the one story to similar stories. One story to similar stories, then select all the plan view so that columns are added. Then go to quick draw beams or columns. Select the property as beam auto column. Beam auto select the property as beam auto select, then select all the region. Then the beams are added. Then go to the quick draw slabs. These are the shortcuts. Here in this we will go to draw floor or wall objects, go to quick draw floor, and the shortcut given here is quick draw floor or wall. Here select the property as slab 150, select the total slab. The slab property have successfully added for similar stories 1 to 8. Then go to the story 9, click on apply, click on OK. Select particular region, go to quick draw columns, columns are added, quick draw beams, beams are also added. Then go to slabs, quick draw slabs, select each slab, slabs are also added for story 9 to 14. Then go to the plan view and select the story 15. then apply, then OK. Select particular region, here the slab properties are added. Go to quick draw columns, then draw the columns, then go to quick draw beams, slabs and column and beam properties are added for stories 15 to 19. Go to story 20, apply, then OK. Go to quick draw column, then go to quick draw beams, then go to quick draw floral wall. Select the slabs, then go to the story 1, apply, then OK. Here select this one object, select the shells, select here, change this similar stories to all stories, we are applying loads here. All stories are selected, and also similarly shells are also selected. Now assign the shell loads. Go to assign and go to shell loads, then go to uniform, then dead load as 2 kN per meter square, then apply and then OK. The dead load for all the stories have been successfully added. Then change the all stories option to similar stories option. Select the shells, go to assign menu, go to shell loads, then uniform, then load pattern as live load, and the load given as per question is 5 kN per meter square. Click on apply and then click on OK. Here then go to the story 9, apply, then OK. Select the shells, assign the loads. Go to assign, go to shell loads and then uniform. The load is 4.5 kN per meter square. Click on apply and then click on OK. Go to the story 15. Click on apply and then click on OK. Select the shells, assign loads, shell loads, uniform, 4 and the load is 4 kN per meter square, and then click on OK. Go to the plan and go to the story 20 to 23. The load is 3.5 kN per meter square. Apply and then click on OK. Then select the shells, then go to assign, go to shell loads, uniform 3.5, apply and then OK. Go to the story 1, apply and then OK. Here select similar stories, select the frames, edge frames only. For similar stories we are selecting the edge frames only. Then assign the select the edge frames here again. Carefully select the frames here. Left side bottom we will know the frames. Then assign the frame loads. Go to assign, frame loads, distributed. The uniform load given is 0.2. Similarly do for all the stories. Go to the story 10. Go to the story 9 and then apply, then OK. Select the edge frames only. Here all similar stories option is not visible, so go to the display and click on undeformed shape. Similar stories option is visible. Click on the edge frames only. Then go to assign menu, click on shell loads, click on uniform, frame loads, sorry. Go to assign menu, go to frame loads and then go to distributed loads. Here the load is 0.2 km per meter. Click on apply and then click on OK. The loads have been successfully added. Then go to the plan view and go to the story 15. Click on apply and then click on OK. Select the edge frames only. Carefully select the edge frames. So go to the assign menu and then click on frame loads, go to distributed, click on apply and then click on OK. Go to the plan, then click on story 20, click on apply, then click on OK. Select the edge frames. Similar stories option is not visible, so go to the display menu, then click on undeformed shape, similar stories, then select the edge frames carefully. So the edge frames are selected. Then go to the assign menu and then frame loads, distributed, apply and then OK. Go to the plan view, then go to the base, apply and then OK. Here the stories option is not visible, so go to the display menu, click on undeformed shape, then click on one story option, then select the total plan view, then assign the joints, go to the joints and restraints, click on fast restraints, then click on apply, then OK, since the joints have been added to the base floor. Then go to the draw menu, click on auto draw cladding, use floors option, then click on OK. In 3D view, click preview. The auto draw cladding also have been successfully added. Then we will apply the wind loads. For wind loads, we will use the code IS code of IS 875/1987 part 3. Wind loads are considered. Go to the define menu, go to the load patterns, type here wind, and the type as wind. Here the code is 875/1987. Add new load, go to the modify lateral load and the wind speed, the given parameters are in Bangalore, so the wind speed given in the map. So in the selected region of Bangalore, the wind speed is given as here 33 kilonewton, 33 meter per seconds, and the terrain category is located, since the parameters are in Bangalore, the terrain category is 3. Structure class, for the structures greater than 50 meters, the structure class is C, and this coefficient and topography factors are 1. For Bangalore, upwind slope in 3 degrees, the topography selected as 1, then click on OK, then click on OK, then click on the elevation, go to the elevation of A, and then apply, then OK. Sorry, click on plan view, here this one 3D view, here plan view, click on plan view and go to the elevation view, click on A and apply, then OK. Then here select one story option to all stories. Here select all the shells, only shells. We will see that frames are also selected. Shells have been added. Then go to assign. In this we will use the codebook of IS 875/1987 part 3, table 4. Height of the building is since here the stories are 23 and height of the slab is 3 meters, so 23 into 3 is 69, and the width is 18 meters, that is 3.83. that will lie in between height by width. Height by width will lie in between this, and this is the coefficient for A, B, C, D. For A, for elevation of plan A, this is 0.8. Then go to ETAP software, then click on assign, and then click on shell loads, then go to wind pressure coefficient as 0.8, 0.8 windward, then apply, then OK. Next go to the select the elevation B, apply and then OK. Here make sure that selection of the all stories have been done, then select all the shells here, only shells, not the frames. Carefully select the shells. See, frames are also selected. So shells are selected, then assign. Go to shell loads, then go to wind pressure coefficients. For elevation B, this is 0.8 and that is windward. Apply and then OK. So check in the plan view how the loads are applied. Go to the plan view and go to the story 1 option, then apply and then OK. Here the loads are applied in this direction, inward direction. Then go to the elevation and go to the option D, elevation D, then apply, then click on OK. Select all the, make sure that all stories are selected. Select the shells, carefully select the shells. Go to assign. Go to frame loads, go to shell loads, then wind pressure coefficient, and the coefficient is 0.25. For elevation D, that is leeward, 0.25 in IS, given as per IS codebook, then click here. Select the shells. Then assign, go to shell loads, go to wind pressure coefficient, leeward, select as leeward, apply and then OK. In leeward direction the loads are applied. Then go to the elevation, go to the elevation C, then click on apply, click on OK. Select the not frames only. Select the shells. Then assign, go to assign, then shell loads, then wind pressure coefficient minus 0.25. Click on apply and then click on OK. Then go to the elevation, select the section 1, click on apply, then click on OK. For sections 1, 2, 3, 4, the wind is same. Select all the shells. Go to elevation and go to section 2, then click on apply and then click on OK. Then go to 3, third section, click on apply and then click on OK. Select the shells. Then go to the section 4, click on apply and then click on OK. Then go to assign, go to shell loads, then wind pressure coefficient, change the coefficient to minus 0.8 in leeward direction, then click on apply and then click on OK. You can check the loads on the plan view. Loads are applied in each side, so go to the plan view, and click on any story, click on apply. Here the loads have been applied in all the similar stories. Go to the second set of similar stories, then click on apply, then OK. Here the loads are applied to the exterior shells even if they are in the interior grid section, and all the directions are also correctly selected in this way. In this way you can verify the wind load in another set of stories as well. Now we will run and analyze the building model. Then select the object, this one, go to the toolbar, extruded view toggle, use extruded view, select the 3D view and use extruded view. Since the building is selected in extruded view, here we'll see the building in 3D view. Now go to analyze and run analysis. As the number of stories is more, the software will take the time. Then go to, we have to save the model, then we will go to analyze and go to the run analysis. Since the number of stories are more, the software will take the time. At the bottom, check the bottom part. Once analysis is complete, we will check the displacement values. Here analysis is completed. Right click on any point to check the displacement values. See here the displacement values are shown. Then we will design. We will run the design. Go to the design. Go to concrete frame design. Go to start or check design. Wait for some time. The software will run design of your building. Once the design is complete, we will get the notification. Since the analysis and design sections differ for 705 concrete members are failed here. Initially software used a similar concrete frame from auto select list, which is 500 by 500 section for column and 500 by 300 for beams. In this case, out of number of 705 frames fail the design check. Thus the software asks permission to reiterate analysis and design. For 705 fail frame members, change it to next higher section, 550 by 550 columns and 550 by 350 on beams. Click on S and software will increase the dimensions, failed frame section from auto select list, and will automatically run analysis and design. Click on S. Wait for some time. Then go to the design and verify that all members are passed. Go to the design, go to concrete frame design. Here verify all members passed. Click on this. Since all concrete frames passed the design check, there is no failed member in the design. Thus design of the building is completed. And right click on any beam to check the design. Here left side the reports are also obtained, project report and summary report. We can check the total tall building design report and summary of the report. Thus analysis and design of the tall building of 23 story has been completed. Thank you.